Let's talk about the traffic light, the everyday device that keeps our cities from descending into chaos. It all began in 1868 London, with a gas-lit, manually operated signal. It exploded after a month, injuring a police officer. Despite the rocky start, the idea survived. As cars took over, American cities like Cleveland and Detroit experimented with electric versions. In 1920, Detroit's William Potts added the yellow light, creating the three-color system we know today, a true game-changer for safety. Early lights ran on fixed timers, oblivious to real traffic. You'd wait at a red light at 3 a.m. with no cars in sight. For decades, traffic lights didn't adapt. They just cycled through their routine, regardless of jams or empty roads. These were dumb systems, reliable but inflexible. As cities grew, this approach just couldn't keep up. The challenge? How do you make a traffic light aware of its surroundings? Enter modern engineering, sensors, data, and smart programming. The goal? Transform the stoplight from a simple timer into a dynamic, responsive system that manages traffic flow in real time. This leap, from basic stoplights to smart traffic management, has reshaped urban mobility. Today's systems use technology to adapt, making intersections safer and more efficient. It's a story of innovation, from gas lamps to intelligent grids. So, how do these smart systems actually work? Let's dive in and see how traffic lights got their brains. From chaos to control, the evolution of the traffic light is a tale of necessity and ingenuity. And it's only getting smarter. Ready to see what's behind the green, yellow, and red? Let's go. How do you give a traffic light senses? Not with eyeballs, but with sensors. The classic inductive loops, coils under the road that detect cars by changes in magnetic fields. Modern systems add cameras, analyzing video to count cars, track movement, and spot congestion. Radar bounces radio waves to measure speed and distance, working even in bad weather. Infrared sensors detect heat, great for spotting bikes or pedestrians that loops might miss. Each sensor has strengths, but the real magic is sensor fusion, combining data for a complete picture. Inductive loops, cameras, radar, and infrared all work together, giving the system eyes, ears, and touch. This multi-sensor approach lets smart lights truly see what's happening. That's how intersections get smarter and safer. All those sensors feed data to a computer, the traffic controller, at each intersection. Its job? Decide when to turn lights green, yellow, or red based on real-time conditions. Unlike old systems, smart controllers adjust instantly. If a side street car appears and there's a gap, it gets a green without waiting for a full cycle. After big events, cameras spot long queues and the system extends green lights to clear congestion. It's not just about cars. Emergency vehicles can trigger green lights as they approach, clearing a path in seconds. Smart systems also prioritize buses or bikes, making streets safer and more efficient for everyone. The result? Less waiting, smoother flow, and faster emergency response. Real-time data means real-time decisions. It's a leap from rigid routines to dynamic, responsive control. That's the power of smart intersections. Now let's go beyond reactive systems. Enter AI and adaptive control. AI learns city traffic patterns, predicting jams before they happen. It analyzes historical and real-time data, adjusting signals for holidays, weather, or sudden events. If traffic builds up unexpectedly, AI reroutes cars by changing lights blocks away, preventing gridlock. The system constantly refines itself, learning from every rush hour and rainy day. It can even spot patterns, like slower traffic on rainy days, and adjust timings automatically. After big events, it creates green waves to clear crowds efficiently. Machine learning means the system gets smarter over time without manual reprogramming. It's like playing chess with traffic. Always thinking several moves ahead. That's the future of adaptive traffic control. One smart intersection is good, but a network is transformative. Connected lights communicate with each other and a central command, coordinating citywide flow. The central system sees the big picture, adjusting signals across neighborhoods to prevent bottlenecks. Green waves let cars hit a series of green lights if they travel at the right speed, no more stop and go. The network adapts in real time, handling accidents or events by rerouting traffic and updating signals instantly. Digital signs and apps keep drivers informed, turning chaos into controlled flow. It's holistic management. One incident won't paralyze the city. This orchestration is the difference between gridlock and smooth movement. Networked systems are the backbone of modern urban mobility. That's how cities keep millions moving. This isn't sci-fi. Cities worldwide are already using smart traffic grids. Los Angeles has equipped every intersection with sensors and cameras, cutting travel times and stops. Singapore's system integrates data from sensors, buses, and taxis, adjusting signals and even using congestion pricing to manage flow. London's Scoot system adapts signals in real time, reducing delays and giving buses priority. These cities prove smart grids work, improving commutes, public transport, and air quality. It's not about building more roads, but using what we have more efficiently. The results? Less gridlock, cleaner air, and better quality of life. More cities are following suit, investing in intelligent transportation. The future of urban mobility is already here. The benefits of smart traffic systems go far beyond saving time. Smoother flow means less idling, lower emissions, and cleaner air. Commutes shrink, stress drops, and emergency response gets faster. Public transport becomes more reliable, encouraging people to leave cars at home. But challenges remain. Privacy concerns over cameras and data, and the cost of upgrading infrastructure. Cities must be transparent, protecting data and building public trust. As vehicles get connected, they'll talk directly to traffic lights, enabling even smarter coordination. Smart lights are the foundation for future cities, supporting everything from autonomous cars to drone deliveries. They're the silent conductors of our urban symphony, keeping us moving, and that's a future worth building.